Hello again, 8th graders, and welcome back to my YouTube channel. I wanted to talk about a couple of things I more or less glossed over at the beginning of the unit when we were talking about these ways to solve systems of simultaneous equations. They say simultaneous because the idea is they're, of course, when you're presented two different equations and you're going to graph them, where they intersect is going to oftentimes be a point of interest. So obviously that intersection can be shown visually when you graph them on paper, but that's a little bit imprecise, as I've mentioned, and I've now this week taught to you during our live sessions two algebraic methods. One was called the substitution method, the other one was called the combinations/elimination method. You hear them referred to by both names. So anyhow, what I wanted to talk about here, though, because when I went over this on, I guess it was Wednesday's notes, I had mentioned, one solution is a consistent independent system, which is pretty simple. You'll have, two different graphs. Maybe it looks like this, on your grid. And, okay, so again, let's say that's our x-axis, here's our y-axis. Fine. All right. And of course, I also mentioned that infinitely many solutions will look kind of like this, where you've got maybe an equation of a line that looks like this, and then the second equation winds up overlaying that one perfectly. That's where you have this going on. That's infinitely many solutions. And then those solutions, of course, are going to be where you have some graph and you wind up with nice parallel lines. Give me a second, there we go. Close enough. All right, so again, if that's a graph and this is a graph, yeah, that's going to be an example of an empty set or no solutions, okay? Again, no solutions, that's where you're going to say empty set. Okay, now, what will this look like algebraically when you're doing these substitution or elimination problems? Well, I'll start with substitution and talk about, for instance, let's say you had, let's say you did y equals 2x plus 3, okay? And then let's say we had negative, let's go with negative 6x plus 3y equals 9. All right. So if I ask you to solve this system by substitution, this kind of cries out for substitution because I already have this here solved for y, so I can substitute this in. And okay, so I have that negative 6x plus 3 times, and I leave space for an expression because I'm going to replace y with 2x plus 3. I have to use distributive property, of course. And you can see that I'm going to have negative 6x here plus, 3 times 2x is 6x. And the positive 3 times positive 3 is 9. That's great. So, equals 9, like so. Negative 6x plus 6x, whoa, this goes poof. A little bit unexpected because, now I just have 9 equals 9. When you get an identity like this, and it's not in terms of a variable here, folks, an expression like this is an identity. This is going to be an example of a problem where you're going to say that there's an infinite number of solutions. That is, infinitely many solutions. Note I didn't say infinity. Don't say infinity. That means something else. I want to say there's infinitely many solutions, or there's an infinite number of solutions. When you get an identity, that's what you're going to have. On the other hand, now I'll use the substitution one here for, I'll use the same thing here, but, or at least that same first equation, because I'm just not all that creative. But then I'm going to say equals, I'll say 10. Now watch what happens, of course, when I go to substitute this in. And you say, well, isn't that going to be the same thing, except what's going to happen here? Negative 6x plus 3 times 2x plus 3 equals 10. I have 6x plus 9. So much like I was dealing with before, again, I get this cancellation here, but I do not have an identity. I have a false statement. I have a false statement, folks. So when that happens, that is when you have an indication that instead of infinitely many solutions, you actually have parallel lines. There is no solution for an empty set, or of course you can use the symbol for empty set, the Danish letter there, like that. Okay, so that's what it looks like when you have infinitely many solutions versus no solutions when you're using substitution. Again, it's worth highlighting. This is infinitely many solutions. I'll even change my color here. A false statement like this is where it's going to say no solution. Understand? Sometimes the most common mistake with this I get is with kids that will say, oh, so it's x equals 0. No, no, no. When the variable's gone, it's gone. It's not going to be x equals 0. Okay. When solving systems of equations that involve combinations, what will this situation look like? Let's try it out for size here. Consider. This one I'll say we had 2x plus 5y equals, let's say it equals 14. And then on this one I'll say we have, negative 4x minus 10y equals negative 28. Okay, so on this one, based on the combinations method I just taught to you, you should be looking for numbers that are going to cancel. I can multiply by that'll cancel the x's or cancel the y's. In this case, I look at this and say, oh, right away, if I just multiply this top one times 2, I'll be able to cancel the x's, and that's great. So I'll now have positive 4x plus, and then I'm going to have 10y, and that equals 28. And so now when I go to solve this system here, by addition, this goes poof, so I have no x, plus, I've got no y, and it equals 0. So 0x plus 0y actually equals 0. So again, with the identity, when you have an identity such as this, you're going to say there are infinitely many solutions. Okay? So, infinitely many solutions. Good. And then, of course, if I'm solving by elimination, and let's say I have this, and let's say on this one, let's say we have negative 9x plus 21y equals 4. All right. So on this one, again, use your elimination techniques. So I look at this, I say, I can eliminate the x's if I multiply by negative 3. Fine. So now I'm going to have negative 9x plus 21y equals negative 30 for that top one. The second one, I'll just keep it the same. I don't need to transform it to be able to eliminate the x's. Oops, and you know what I just realized? I wrote, that's good. Negative 9x plus 21y equals 4. And that's great. Oh, wait, this sometimes happens. We'll say, wait, if I'm adding these, they're not going to cancel. That's okay, because when you're solving a system, subtraction works as well. Negative 9x minus negative 9x is still 0x. 21y minus 0y, or 21y is 0y. Negative 30 minus 4 is negative 34. So again, I've got 0x and 0y, but now I've got 0 equals negative 34. So again, with the false statement, and when that happens, folks, you are going to need to say that there is no solution, that there is an empty set. Okay? I hope that clears things up, and that you're now able to complete exercises 125 through 129. Just sort of circle back on those now that you have an understanding of substitutions and combination methods as well. That'll help you out and hopefully in understanding those exercises. So ultimately, you should really be through exercise 145 by the time we reconvene class. Okay? I will see you the next time. Be good for your parents and have a great rest of